Next up is quotient rule. Quotient rule is very similar to product rule in that it is used when you have the derivative of a quotient. A quotient is when you have an x in the numerator and an x in the denominator. So it's like a function in terms of x over a function in terms of x. So you can see this as an example. 5x minus 2 has an x in it. X squared plus 1 has an x in it. So this is a quotient, and we will need to use the quotient rule. Again, it's because there's an x on top and an x on the bottom, and there's no way to simplify this at all like we've done in the past with quotients. This is as simple as it can be, and so we would need the quotient rule for this. The quotient rule is here, and it is v u prime minus u v prime all over v squared. So in order to do the quotient or the derivative of any quotient, you would need to apply the quotient rule, and this would be the answer to the derivative. So again, you want to make sure that you define your u. Here your u is 5x minus 2, and define your v. Your v is x squared plus 1. Now as you go through the formula, every time you see one of those letters, you know what to write. So f prime of x, which means the derivative of f, the derivative of this is going to be this formula, plugging these things in. So v is x squared plus 1. U prime is 5 minus u is 5x minus 2 times v prime, which is 2x. It's all over v squared, so it's x squared plus 1 squared. Oops, I'm sorry. All right. So this is your derivative. You'll want to simplify as much as you can. The bottom is simplified because it's already factored. I would not write this twice and FOIL it. That would be like unfactoring, and that would make it not as simple. On the top, because we've got some factors that are separate, we're going to want to distribute the 5, distribute the negative, and distribute the 2x, and then we can combine like terms. Because the top is separated here with these parentheses, we can't combine like terms yet. So we are going to do some work on the top. So the top would be 5x squared plus 5 minus 10x squared plus 4x all over the bottom, which I'm not changing. So the top, it looks like we can, again, combine some like terms. So negative 5x squared plus 4x plus 5. And the bottom stays the same. So that is my derivative.